Monday we created Taylor polynomials. Okay, we can actually approximate polynomials. Or excuse me, we can approximate functions with an infinite polynomial. Well, not infinite, but we'll eventually get to infinite. Okay, the more terms, the better. Over the interval of convergence, okay? So e to the x, we centered this at 0, right? And right now I have a third degree polynomial. The more terms we add, the closer it's going to be around 0. It's always going to be exactly at 0, but as we travel along away from 0, the more terms we add to our polynomial, the closer that curve is going to be. So, we have what's called an interval of convergence, okay? How far away from the center is this going to be a legitimate approximation, okay? So, we have what's called a power series. Yeah. This is where all of those tests for convergence come into play. Potentially.
Oh gosh. Do we need to write all of this down?
I would at least write the first one down. I don't know if you need the second one. It's just centered at a. Do you see the difference between the two? How this one is x to the n, this is x minus a to the n. This first one's centered at 0, the second one is centered at a.
I heard that Omaha North got rid of that guy.
On this one, did you hear about Burke?
Yeah, you hear about them? They're filthy cheers. They had to forfeit 5 games.
Why?
Because they had an ineligible transfer from Millard West.
Whoops.
But they probably didn't even know because he only scored 10 points the entire season.
That's too bad.
So he's really not.
Nick, let me know when you're ready.
I hope that was one of our games.
So does this mean that series will even like the main part?
Yeah.
I'm good.
Yeah. Yeah.
I feel like
Okay, so we want to know how far a power series converges. How far from the center can we deviate for it still to be true? Okay. So these are our possibilities. It might only converge at where it's centered. It could converge on an interval. Don't write all the words, maybe just draw the pictures, okay? Or it could always converge. I had 2 boxes yesterday.
I've had one classroom today with Kleenex. It's been a rough day.
English?
No, well, 2 classrooms.
Okay, so do you see how in the second one there exists a real number r greater than 0 such that the series converges for the absolute value of the quantity x minus c less than r and diverges when it's bigger than r? What does that mean? What is r? What is an R word that we like to use in geometry?
Rhombus. Rectangle. Right triangle.
Respect.
Respect is a great one. Respect is a great one. But it actually stands for radius. Radius.
That's a small
Big R in this chapter is radius. Radius for radius of convergence, not radius of a circle, which is why it is not little r. Okay? So R is the radius of convergence. So how far from the center will this still converge? That's what that R is going to mean. Okay? And that's a lot of what you're going to do in this section. What is the radius of convergence? How far away from the center does this converge? Okay? So, this is what can happen. Okay? We've already talked about how we can converge at a single point versus an entire line. When we find the radius of convergence, we then need to look at the endpoints to see if our interval converges at the endpoints r away from the center. Okay, so you can see here the different cases that we can have. Okay, we can converge at a single point, we can converge entire line, we talked about that. But then we're going to have an interval, and then we need to check, does the right endpoint make it still converge? Does the left endpoint make it still converge? And so then we have an option, we have 4 different options for what our interval could look like. Let me ask you this. If our series only converges at the center, what's the radius? 0. If we always converge, then our radius is infinite. Okay. So when we're talking about a power series, this is one that you are going to eventually recognize. Okay. E to the x. If we take each derivative and evaluate it at 0, we get 1, 1, 1, 1, 1, 1, 1. Okay. So when we write the power series, it looks like this: the sum from n to infinity of x to the n over n factorial. Okay. Well, how do we find the radius of convergence? How do we know how far away from the center this will actually work?
ratio.
Hey, how do you know?
It's your favorite text.
It is my favorite text, okay? That is how you're going to find the radius of convergence. And we're not actually going to do it for this, and we're going to do it for this example right here. In order to find what the radius of convergence is, we are going to use the ratio test. Read my mind.
I don't know what ratio should be used.
What?
I don't know what ratio should be used.
Okay.
Maybe tell them to get that marijuana. Party time.
Okay, so ratio test. The limit as n approaches infinity of 2x to the n plus 1 over n plus 1 squared times n squared over 2x to the n. Okay, so we have n squared over n plus 1, the quantity squared. And then how would we simplify 2x to the n plus 1 over 2x to the n? 2x? This goes to 1, which means our limit is the absolute value of 2x. Now, awkward, we have that x in there, we're not used to seeing that. But what do we know about the ratio test? It converges when our limit is
Positive. No, less than 1,
less than 1. Okay, so that means the absolute value of x needs to be less than half. Our radius of convergence is
Such as a radius. Possible.
so from the center, we can be forward 1/2 or backwards 1/2 and still converge. Up to 1/2.
What if you were 1/2 in the z?
What?
What if you were 1/2 in the z plane?
We're not talking about that.
Can you do this for us instead?
I only know how to do this in 2 minutes.
So
Can we
maybe
do it?
I don't know the answer to that question. All right, let's change things up a bit. Just for you, Isaac Warner, right here, we have 2n factorial.
Because I don't like this.
I'm just gonna do ratio again.
That's what I do. I don't like this one.
Well, Grayson, you will do the ratio test for all of your radius of convergence.
Is that the only one we use in that equation?
No.
No?
Does that mean we're
Radius
gonna
no nth term because we always check that first.
Is there gonna be some past information?
So is it gonna be 2 quizzes combined?
Oh,
That's what I'm wondering.
I'm scared. I wish I had a review. It's comfortable.
Your review is your homework.
But it's
So
only
what
gonna be over
homework?
this.
It is a sign quiz.
But our homework's only gonna be over this section.
Yeah.
So it's not really review, except for 1 and 2.
Yeah, what homework is it in?
Is there gonna be like
I don't even know what sections it's in.
alternating series tests, that kind of stuff on there?
Can we just get through this lesson and then worry about it?
Sure.
Okay.
Will we have time?
Why do I have 2n plus 2?
Because you have to
We can
distribute it.
Because we have to distribute it. Okay, thank you. Now, what do we have? We have 2n factorial over 2n plus 2 times 2n plus 1 times 2n factorial. That is how you would reduce that. Times, when we reduce this, we have 2x, the quantity, squared. Doesn't really matter. Why? This limit is okay. Tell me this. How often is 0 less than 1? So our radius of convergence is infinity. 0 is always less than 1. It's always going to be true no matter what we plug in there for x. Therefore, our radius is infinite. Okay. Now, didn't I talk about an interval of convergence?
Yes.
I did.
So here it is.
The integral
Okay.
of the integral.
We'll go backwards. So, what was our radius of convergence here?
That's the recent one or the one before?
Infinite. So our interval of convergence please know the difference between when I ask for you for a radius of convergence versus when I ask you for the interval of convergence. Radius is how far away from the center we converge. Interval is the actual interval. Okay? Now, let's go back up to the first example we did. This one. what was our radius of convergence? Our radius of convergence was 1/2. How do I know where this is centered at?
N equals 1. Plug in 1.
Well, it's just X.
X to the n versus x minus a to the n.
Oh, 0.
So this is centered at 0. So 0 plus 1/2 and 0 minus 1/2. What we need to figure out is if we converge at the endpoints. What'd you say?
Plug it in.
Plug it in.
See what the heck happens.
And this is where your knowledge of series tests is going to come in handy. What is 2 times 1 negative 1/2?
Negative 1.
We have negative 1 to the n over n squared.
That's an easy conversion. Absolutely.
0.
So we can include negative 1/2.
True.
Alright, now we're gonna be possible.
Tell me what you're using so I know.
Alternating series test.
Okay.
Decreasing and limiting 0.
But you don't have to put all that stuff there for me. You can do that in your head. Next, if we plug in 1/2, what is 1/2 times 2?
1.
Thank you.
Alternating.
So we have 1 to the n over n squared. What's 1 to the n?
1. Actually,
Well,
1
that's
to the
anything that, you know, it's.
That is not.
How do we know n's not infinity it goes to infinity? So that's actually indeterminate over n squared.
True.
It's 1. What do we know about this series?
That's not what we've learned.
Converges.
Series.
P series. So this interval that we have going on here is inclusive of both endpoints. What'd you ask?
Our math classes ran like this in college.
What?
So, like how we do it in high school.
Not at all.
It was a lecture. They're easier.
That's why my sister got like 106 in calc in college, and she was like, "Wow, that's so cheap."
Questions on this?
How are they easier?
Questions?
They don't learn as much.
Really?
They go at a faster pace though. Oh, look at this one.
Do they do like the same kind of like class structure? Do that? Obviously, you're not saying it doesn't exist. But
You're in a lecture hall.
One of my
They don't ask as many like
goals
to you.
they just do it.
Yep.
It's the end thing, and then you have to
Where is this one centered?
decide.
5.
5. This is centered at 5. Okay. So let's see, how does this affect finding our interval of our radius of convergence? And then what do we do with that radius to get the interval? So, ratio test. Let's go. Okay. I'm just going to do this. That negative 1 to the n plus 1, what happens when we put it in the absolute values?
1.
I'm not going to write it.
Okay.
Okay. So let's talk about this. We have x minus 5 n plus 1 over x minus 5 to the n. So that's just x minus 5. We have n over n plus 1. And we have 5 to the n over 5 to the n plus 1. This limit goes to 1, right? So we have the absolute value of x minus 5 over 5. And that needs to be less than 1. What is our radius of convergence?
Be less than 5.
5 is our radius of convergence. Okay? When you get x minus the center alone on the equality side, or with the inequality, I'm sorry, that other number is your radius. So since I have x minus my center is less than 5, 5 is my radius of convergence. Does that make sense? Okay, so let's talk about our interval. Our interval, we're centered at 5, our radius is 5, so our interval goes from
0 to 10.
0 to 10. Add 5, subtract 5. Now, what do we got to figure out?
We got to leave it in.
We got to figure out if we converge at 0 and if we converge at 10. Yikes. Okay, so what do you want to plug in first?
0.
Okay.
We do not sometimes it's working with
So when we plug in 0, we have 0 minus 5 to the n over n 5 to the n. Okay. We gotta rewrite this, okay? When we have a negative number to an n, this is what I want you to do. I want you to write it as negative 1 to the n times whatever that number is to the n.
We'll make it easier.
Yeah, well, because you have that alternating piece there. Okay? Well, now, because we did that, what can happen? These cancel, right? Now, I have negative 1 to the n plus 1 times negative 1 to the n. What do we do with exponents when we're multiplying? Two n plus 1. What kind of numbers are those? They're always odd numbers, aren't they? So we have negative 1 over n.
divergent.
That's a divergent p series. We have negative 1 over n.
So 0 is not.
So we're going to put a parentheses around 0.
I have a question
I have an answer.
for inequality. Don't 0 and 10 not work anyway? That's what I was thinking.
Well, remember the ratio test is inconclusive at 1. Which is why we have to test the endpoints, because that would be the equality. All right, now let's test 10. So we have negative 1 to the n plus 1, 10 minus 5 to the n. Okay, so here the 5 to the n's cancel. And we have negative 1 to the n plus 1 over n. What do we know about that series?
Or, no, it doesn't. I think it just
It converges because it's an alternating series that
Negative and
has the limit and it's decreasing. Okay, so we can put. Okay, really alternating series, p series, geometric. Those are going to be more of the ones that you're going to see. You don't have to show me the work on your endpoints for alternating series test. You can do it in your head. For your interval of convergence, Just tell me the test that you're doing in your head. Okay? Will that work? Are you going to show me that work?
Yes.
Okay.
So those are the ones that we have to know.
One more. What did you say? Did you say something, Nick? Well, the ratio test, because we did the ratio test to get 5, right? Well, we don't know what happens if this limit were to equal 1 that's inconclusive. We know that it's valid for less than 1, which is how we get the less than 5, right? But we don't know anything about when this limit equals 1, which would be in this case 5, when we multiply that over. Okay, so we have an interval from 0 to 10. We just don't know what happens at the end point. So we have to check it by plugging in 0 to x and see if that series converges. It didn't. Plug 10 into x, see if that series converges. It did. So 10 gets the bracket, 0 doesn't.
Oh, I got that. I just didn't get why. How come 0 converges to 10? Yeah, or how come 0 back? Yeah, that's what I was asking.
Could you plug it into x minus 5?
Because when we plugged it into x minus 5, we got negative 5 to the n. We wrote that as negative 1 to the n times 5 to the n, and those canceled out. Okay? Then these two we combine to be negative 1 to the 2n plus 1, which is just negative 1. So we got a p series where p is 1, and those diverge.
Negative 1 over n diverges.
Yes.
It's a P series.
It's also
That's because it's just gonna be odd and you're just gonna get negative values.
Oh, okay.
It's not an alternate series.
Guess what? This is...
So, yeah.
No, this is so cool. This is so cool.
Do you have to do this on the whiteboard?
What?
Yeah.
This looks confusing.
This looks like something
I
like
think we have to call it a day. We don't know.
No. This is so cool.
You don't have enough time to talk about
Oh no, you should think of this way, it was fun.
We'll talk about something on the quiz tomorrow.
It's really massive.
Yep.
The radius of convergence is going to be the same for f prime and the antiderivative of x. So, f prime of x guess what? We have x to the n power. How do we take that derivative?
Is it always the same?
Like that, right? We're taking the derivative with respect to x. What was the radius of convergence here? It was 1/2, wasn't it? Guess what? Radius of convergence, still 1/2.
Which says this one.
The radius does. You still have to check the endpoints, though. The radius stays the same, but you have to check the endpoints independently. How about this? The antiderivative of f of x dx. Well, that series would be n equals 1 to infinity of 2x to the n plus 1 divided by n plus 1. It's just the antiderivative, right? Yep, missing one thing.
Yes.
Same thing up here. I forgot my chain rule. I apologize. No, I'm so sorry. Inexcusable. Inexcusable! Isaac Warner,
Actually.
what is our radius of convergence?
1/2. Are we gonna test the points?
We won't take time in class to test the points. Okay, I feel like we did it 4 times, it's the same story.
So
over
then
and
we
over.
plug in more negative on it.
Right, so our intervals would still be -1/2 to +1/2, but you would just have to determine whether you have brackets or parentheses. Okay? Your quiz tomorrow.
It's formative.
It is formative. 2 Taylor series, 2 LeBron Jared.
How do you say
LeBron.
LeBron.
1 radius of convergence. And then a couple intervals of convergence.
So it's short.
It is short.
Did you miss something?
There may or may not be a take-home portion, so that the in-class portion can be short, so that we can discuss problems at the beginning of class.
What?
What did you speak?
But I appreciate the effort there. Is this what you did yesterday?
LeBron James.
No, we can't do
No,
that.
we didn't even think of LeBron
We
James
started talking,
yesterday.
let's get to work.